Hello, and thank you for the invitation to speak at the ICOTEC conference this year. My name's John Collomosse, and I'm a professor at the University of Surrey, where I direct the Decade Research Centre for the Decentralized Digital Economy. And I'm also a senior principal research scientist at Adobe Research, where I run the research programs for their content authenticity activities. My talk today is about media provenance, which has been a big focus for our research group and our standards work over the past several years. And I'm going to talk about how it can help us address the problems that we see in the age of generative AI around fake news and copyright. In particular, the main takeaway of this talk is that by knowing more about the provenance or origins of a piece of media, like an image or a video, we can address both this authenticity challenge and more fairly recognise and reward the rights holders of creative media when it's used, for example, to train generative AI. So I'll get started. So let's start with the fake news problem. I guess everyone has their favourite motivational slide when they start talking about the problem of fake news. Mine is a photo that I took in the UK National Archives about 10 years ago when I was running my first research programme in media provenance. It was called Archangel, and we were exploring the combination of visual fingerprinting and blockchain. These are two technologies I'll speak more about in a moment, to safeguard the integrity of public archives. And the image itself is a proclamation dating back to the time of King James II, really against false news, so misinformation. And I chose it because I wanted to show that fake news, it's not a new problem to society. Arguably, it's been around since the advent of the spoken word. People have always, unfortunately, lied to one another. And fake images also aren't new. These are famous early examples of fake photos of a girl interacting with fairies at the end of the garden, supposedly. They fooled people for decades until they were confessed by the photographer to be actually just cardboard cutouts at the end of the garden. But of course, generative AI and social media have made this kind of fake imagery all the easier to create and all the faster to share. And that's really the crux of the problem today. The copyright problem, of course, is another aspect of the rise of generative AI and large language models, LLMs. These models are fueled by data at a massive scale. These are some statistics here of some of the current AI models, and the number of trainable parameters, the things that are learned by the models, which are typically correlated to the power and capability of the model and ultimately the amount of data it takes to train the model. These are all really exponentially increasing. And it's reasonable, therefore, to ask, well, where is all this data coming from? Now, in many cases, especially for LLMs, the answer is the open internet. And this raises reasonable concerns over the consent for data reuse and also the compensation of the rights holders for that data. And I guess the central thesis of this talk today and much of our work over the past several years has been that provenance is the solution both to this challenge and that challenge of establishing the authenticity of content. So why is provenance important to help us establish authenticity and fight misinformation? Well, there are a lot of techniques out there already that try and tackle this problem by basically trying to detect deepfakes. Now, a deepfake is just an AI content that has been made for the purpose of deception. So we can't really detect deepfakes. We can detect AI content, right? And when you think about it, that really only allows us to address part of the problem, because not all synthetic content, like AI content, AI manipulated content, or even just edited content, is misinformation. There's plenty of people that use these digital tools for good, to tell authentic stories, right? And conversely, if you talk to human rights organisations, they're going to tell you that most visual misinformation isn't actually AI generated or even manipulated content at all. It's unaltered content that has been used out of context to tell a different story. So via some, miscaptioning or misattribution of some kind. So actually, when we try and fight misinformation by detecting manipulation, we're really only addressing the small intersection of these two spaces. And within that intersection, we're really fighting an arms race with generative AI. And of course, nothing moves faster than generative AI. So how can provenance help? Well, by providing users with more information about the origins of an asset, like an image on this slide, they can make their own more informed trust decisions about the content. In contrast to having some sort of detector to tell them true or false, traffic light style, whether they should trust content or not. So this requires a way then to represent and secure that provenance information, that audit trail about media, as it moves around the internet. And this is where something called content credentials comes in to help. So content credentials are an open cross-industry standard for describing provenance inside the metadata of the asset, like an image on this slide. To give a bit of context about content credentials, back in 2019, several of us at Adobe got together around a table and co-founded an activity called the Content Authenticity Initiative, or CAI. And at the same time, there was a similar initiative called Project Origin. And both of those initiatives joined forces to start a technical standards body called the C2PA, or the Coalition for Content Provenance and Authenticity. Now, sometimes those two things, the CAI and the C2PA, kind of get mixed up, a lot of acronyms, but it's C2PA that develops this content credential standards. And importantly, C2PA is a cross-industry body that's not controlled or owned by any entity or company. Actually, it's developed as an open standard under the Linux Foundation. So, okay, let me explain then just quickly how it works. There's quite a bit of jargon comes around with C2PA, so I'll just highlight the most pertinent parts. That metadata that stores the provenance information, that's called a manifest. Okay, you can sort of see a diagram of it here on the page. The manifest contains provenance facts called assertions, and these can be all sorts of things, like who made the content, how, even using what other assets called ingredients, and so basically describes the full provenance history of the asset, because those ingredients might in turn have manifests and so on, like in a big graph structure. Now, all of this information is kind of wrapped up in a signed, cryptographically signed packet called a claim, and it's bound to the asset, like in this case, the pixels, using a cryptographic hash of those pixels. Now, this solution, this kind of metadata standard, is implemented now by several camera manufacturers. The latest Pixel 10 phone has got it in every photo you take. There's various other manufacturers like Canon, Nikon, Sony put it in their high-end cameras. And many Gen AI model providers will sign their generated content using this standard. So, for example, Firefly, ChatGPT, DALL-E, these kind of models, and also other products like Photoshop and Microsoft Office will display it. So, it's getting quite a lot of adoption, at least in the image space. But how is this useful then? How's it used? Well, okay, basically it's about being able to prove what's true. So suppose I'm a public figure and I always sign my social media posts with content credentials to show that they're authentic. Many platforms will show these credentials now. So here on the left, you can see them showing up in LinkedIn on one of the posts that I've made. Now, suppose some sort of nefarious bad individual decides to create a deepfake of me. Now they can't sign that with my key, my cryptographic credentials, to add those content credentials as me. So what that gives me then is deniability as a service, right? Effectively a way to prove what's true about my posts, and a reason to kind of think twice about content supposedly from me that doesn't have those credentials. So I guess this kind of assumes then ubiquity within a particular channel, in this example, my own content, but we could easily imagine a political party or a news broadcaster like the BBC or any other entity might always choose to sign its content to safeguard it in this way. So that's a kind of news public communication use case. I mean, another use case, there are many of these. One of them could be scientific imagery. So it's kind of a sad fact about generative AI that actually, again, some bad actors are using it to create fake images for scientific publications, particularly, unfortunately, in the area of cancer research. Now, camera manufacturers, as I mentioned, are already including C2PA in some cases in their hardware, largely motivated by this sort of existential risk that inauthentic content poses to them. So why not have, say, a microscope manufacturer injecting this information into images that they capture on their hardware? And what if a scientific journal, wouldn't accept images that didn't have these authenticity markers? I think the scope for applications of this in content credentials idea is very broad. So I guess one thing that's useful to think about when we talk about content credentials is the analogy with food labeling. Some people refer to, in fact, content credentials as being a digital nutrition label for your media. Basically tells us where our media comes from, right? But that label, that metadata or C2PA manifest, is quite often stripped away by content platforms, particularly social media platforms, even those platforms that carry through the indicator, don't necessarily carry through the full provenance history to display it to the user. Most of these platforms actually just strip it away altogether. Also, you can imagine taking a screenshot, taking a print of a piece of media and scanning it in again. These sorts of things obviously are going to remove any metadata that was carried around in the original digital file. So this is why we need a durable form of content credentials. So a durable content credential helps that nutrition label stick better to content using a combination of 3 techniques: invisible watermarking, fingerprinting, and the metadata that I've just been describing. I'll talk more about the watermarking and fingerprinting in a moment. So durable content credentials are there to help these content credentials persist through platforms that don't yet implement C2PA, or through things like screenshots or prints, as I explained. It's important to note, though, that these durable content credentials are not a defense against a technically sophisticated bad actor removing the credential, and this can always be done by a determined adversary to deny service. I'll talk more about that later on. This is about enabling these content credentials to stick through platforms through typical social media resharing. Okay, let's give some examples of how it works. I talked about fingerprinting and watermarking. Let's first of all elaborate on fingerprinting. What does that mean? Well, let's give an example. If I take this generative AI image, you can see it's been generated by Adobe Firefly, which is one of the Gen AI models, as I say, that routinely stamps their content with content credentials, the images that it generates. Now, here I'm taking a photo of that image with a camera off a TV, so the metadata is clearly going to be stripped away, right? But what I can do is take a digital fingerprint of that image from the pixels, and a little bit like a sort of exact reverse image search, I can go and match it to a trusted database and recover the content credentials that have been removed from it through that screenshotting process. And you can see that being done here on the right. The image has been dragged in, the content credentials there have been shown inside this tool by looking them up from that database. Now, that's fine when I forensically drag an image in as a user to examine it, but we can't really expect users to be doing that at scale, for example, as they're browsing the web, as the example shows here. In these scenarios, we need greater automation, right? We need to automatically scan any images for missing content credentials. And in order to do that, we can't really go uploading all of those images as a user sort of views through a web page. There's a lot of reasons that's not going to work in terms of bandwidth, scalability, latency, privacy. So this is where the invisible watermarking can help. It's kind of a convenience. If we can detect watermarks in the image as the user's viewing them on the client side without transmitting anything, like in a browser extension, and there are several of these out there on the market, then we can go and look up those missing credentials when we know there should have been some present. And here, as I say, you can see exactly that as part of this particular product, which is the Adobe Content Authenticity product. There's a browser extension that's doing exactly this using watermarking. Okay, so to recap then, I've talked about 3 technologies. You can think about them as 3 pillars, if you like, technology pillars. First, we've got metadata. So open standards to embed provenance information inside assets in a cryptographically secure, tamper-evident way. Metadata has its weaknesses, though. As I've said, it's super easy to strip, right? So what can we do about that? Well, we have these other 2 technologies. We have digital fingerprinting. So that's your fingerprint that's computed passively from the content, like from the pixels of the image. And we can use that to distill an identifier for that content that lets us do this reverse image search and like look up the missing content credentials using this soft hash or perceptual hash, as it's sometimes referred to, the fingerprint. Now, that's fine, but it's not as exact as a cryptographic hash. So actually, when we sort of tabulate the properties of metadata versus fingerprinting, you can see they're almost entirely complementary in terms of, you can't strip a fingerprint, there's nothing to strip, and you can strip metadata very easily, but then the metadata is cryptographically secured by the hash and the fingerprint isn't. Watermarking sort of lives somewhere between the two, where we're actively embedding an ID inside the image, an invisible watermark, And those watermarks, they're always strippable by a determined adversary. But if it's a robust watermark, at least most benign actors like a social media platform, other content platforms, are not going to remove that as it's being reshared around online. But again, it's this kind of lookup process. We're getting an ID, in this case actively injected, that we're using to recover the stripped metadata. Now, what you can see clearly from this table is that no single technology is perfect, but all three approaches, the three pillars, can come together to create a solid provenance layer if they're combined in the right way. So I'm going to talk about how to do that. Before we do, I'll just say something very quickly about our watermarking approach. The watermarking that we've been using in our research, but certainly the standard as CTPA could use any watermarking technology. The one we've been using and we developed is called Trustmark. It's an open source free watermarking technology. It's on GitHub under an MIT license, released that way to help promote the adoption of durable content credentials. And many of the ecosystem implementers of durable credentials have used it. You can try it yourself in Python. You can do pip install Trustmark. And what does it do? Well, you can see here magnified many times the invisible signal, the watermark, we call it a residual, that Trustmark has put inside the image to carry the message. Notice it's quite different to the other techniques that are open source, these other columns. The pattern you can see here is what we call lower frequency, which means it's much more robust to the transcoding, the modification of the image without degrading visual quality. Okay, so going back to durable content credentials then, I've talked about the value of these three technologies, the three pillars, metadata, the fingerprinting, the watermarking, being combined. So let's just see how that can be done. So let's consider then this web scenario. We've got a browser extension, it's running in someone's web browser, it's reading watermarks out of images as the user encounters them, and it's recovering the metadata once it detects such a watermark on the client side. It's recovering the metadata by pinging a server, basically to look up that manifest, those content credentials that would have been lodged there at the time of creation, right? It's like a copy that's been lodged there. Before it returns those credentials to display to the user, it's going to do a visual check using a fingerprint. This is where the fingerprint comes in. And that fingerprint is going to be a comparison between the watermark bearing image, so the fingerprint from that, and the fingerprint that was put inside that manifest at the time it was created. Okay, and only if they match are we going to return a manifest. And this is going to help us fight problems like watermark spoofing, transference of a watermark from one image to another. So, okay, so I mentioned the lookup of credentials, but where should that database be to perform that lookup? It's clearly completely impractical idea to have some sort of single global database for trust in all media. I mean, imagine the scalability or liability problems. And in fact, what we are seeing is many adopters of content credentials are setting up their own databases. Like, I gave the example of Adobe earlier, been running such a database for several years where their customers can, look up content credentials they've chosen to opt into inclusion in that database when they've been stripped away. Now, if everyone does this and they are beginning to kind of produce these siloed databases, we need some sort of way to orchestrate search across these repositories. And this is where decentralized technologies like blockchain or distributed ledgers can come in. In this example that we built as a demonstrator, we've got a key value store on the distributed ledger, and the watermark ID is being used as the key to look up a value, which is basically the endpoint to go talk to about that watermark, which can be one of any number of vendors that all run these manifest repositories, these databases. And this helps us then provide a single point of indirection to go look up a watermark across multiple providers. In a sense, a way to do federated search. Okay, so that's durable content credentials. Let's talk about how they can be applied beyond that authenticity use case then to content rights and the issue of copyright and AI. This is obviously a huge issue in AI at the moment because rights holders want to express opt-in or opt-out of their use in generative AI. There are two kind of main ways people are doing this at the moment. There's site-based and unit-based. So site-based is where consent is being indicated at the level of a website, usually by some metadata file hosted on the site, like a robots.txt. So, robots.txt is sort of historically how content owners have indicated where and where not search engines can scrape their content from in a website. Now, of course, creators, they often want to get their content discovered, so this isn't really a great solution to sort of throw away the baby with the bathwater, as they say, in terms of excluding themselves from search at the same time as excluding themselves from AI. And there was some recent work done by the IETF, Internet Engineering Task Force, to improve robots.txt as a standard to be able to express those AI preferences. But nevertheless, the big problem with site-based opt-out is that, sort of by definition, it doesn't work when content gets reshared and rehosted on a different site, right? And unit-based opt-out, on the other hand, means that this information moves around, sticks to the asset as it is distributed and reshared online. And of course, this is exactly where durable content credentials come in, because they, it turns out, can also transport this information about opt-in and opt-out. Before we see how, let's talk about the requirements and purpose of opt-in, opt-out markers in this context. I mean, basically they're to deal, as I say, with reuse for generative AI, but at a massive scale. The scale at which content is being used to train AI models is the level of billions of images in these data sets. So one requirement we can see immediately is the need to deal with automation, at that massive scale, to figure out if someone has opted in or out. And that means that these markers must be machine readable. There was some time, maybe last year, for some time, there was some discussion with policymakers, particularly, that opt-out could somehow be addressed using, natural language disclaimers on website. But the reality is that natural language parsing simply isn't there yet in terms of accuracy and scalability to handle that level of volume of reuse. Second, this machine readable form must be interoperable between diverse platforms. So as soon as we start talking about machine readable ways, protocols for interacting across independent interoperable platforms, I mean, we're really talking about a technical standard, right? A way that we can agree for platforms to talk to each other about this stuff. And so much the better if it's an open standard, because then it's patent free, there's often open source tooling, it's lower friction, lower cost for everyone to implement. Finally, there has to be ideally has to be some sort of legal weight behind that standard, right? We can put markers in content all we like, but if people just ignore them because they carry no weight, say in copyright law, then actually they're unlikely to be respected at scale. And of course, there can be other regulatory safeguards you might imagine too, like if someone's put markers in, I talked about stripping, maybe we should perhaps not be allowed to strip those markers back out again in certain circumstances. So yeah, in summary then, this slide's saying that we need open standards for machine readable opt-in and opt-out that hopefully in the future or soon would have some sort of regulatory support. Okay. So I mentioned CTPA and durable content credentials provide this. One of these assertions or provenance facts that you can put inside the CTPA metadata is some granular declaration made by the creator as to whether they opt in or opt out of various different AI use cases, like inference or training generative AI. And you can see that exists today. Actually, here on the right, I've got an example of a photo, and this has a do not train marker embedded in it by CTPA. And here on the left, you can see a commercial Gen AI tool, which is Adobe Firefly, declining to process that image because of that opt-out marker. So durable markers for unit level opt-in, opt-out are actually achievable. They're getting implemented and in use today as a result of this standard, which is great. So does that mean then this AI copyright problem is solved? Well, no, we're only just getting started. When you talk to creative rights holders, they'll tell you that they don't just want blanket opt-in or opt-out. They want granular control over who can use their content for which purposes. And yes, actually, they'd also like to be paid, thank you very much, for the reuse of that content. So in other words, we're really talking about a licensing system rather than a preference system. And in the absence of such a system, you can see creators already sort of turning to technologies basically to try and get some sort of agency and control over their work, like glaze and nightshade. These are techniques that you adversarially watermark your techniques, so it kind of messes up the training of an AI model. This is really sort of indicative of the need to have some mechanism for better control. So we did a bit of work around this related to the recent UK government consultation on copyright and AI. And in the wake of that, we at Decade and the CoStar National Lab in the UK ran a series of workshops with creators and AI developers at the suggestion of our government's Department for Culture, Media and Sport. And the recommendations were published in this report, which is called time to act. Now, there are a number of technical and policy recommendations put forward in that report, among them support for a kind of provenance-backed licensing system built upon open standards like CTPA that allows creators to assert rights and get paid for the reuse of their content. The report builds quite heavily on decades research into media provenance, and in particular, this work we did a while ago called Content Arcs. It's like a technical framework. Without digging into it too deeply today, it's a layered framework that starts with a durable provenance layer, which is here in green. You can see actually here on the left-hand side, we've got provenance standard, CTPA, for example, married with content ID technologies like watermarking and fingerprinting. So essentially that green layer is like durable content credentials, or it can be. Now, CTPA itself doesn't have the ability to express rights and licensing rules. Actually, by design, it avoids that. But it can wrap around other open standards that do, like ODRL, for example. And there are also other ways that you can express important things in this ecosystem, like identity. So again, that's not part of CTPA, but there are community extensions to it, called like Korg, for example, that largely deals with things like identity tokens, even self-sovereign systems. So, you know, when you put it all together, open standards really become the glue then in this framework. And then at the top layer, then it's sort of some sort of automated payment mechanism to compensate creators when those rights expressed by the open standards are exercised. So you can use things like smart contracts or regular payment gateways, and time will tell what sort of gateways and payment methods become emergent in this ecosystem, or even if different ones emerge for different verticals, which I'd say is more likely. Okay. So one really interesting technical challenge in applying that framework for AI is deciding on a model for compensating the rights holders for the reuse in AI training, particularly given the sheer scale of data sets used in generative AI. As I've said, that's can be billions of images, right? And really, to return any kind of meaningful kind of revenue share, you know, for a generated image, we need to identify the subset of that training data that is responsible for the generation of that given image. And this is again a question of provenance, but in this case it's synthetic media provenance, right? A synthetic image, after all, comes from the model that made it. Provenance of that is the data used to train it, and so on. So about 3 years ago now, we came up with a framework to do this called AURA, which stands for Ownership, Rights and Attribution. It's kind of like an earlier version of Content Arcs. And at the time, because that was a kind of in use a lot at the time, we were using NFTs as a way to assert ownership over media. But there's nothing particular about these high-level frameworks that require the use of blockchain or NFTs. Anyway, the idea here is that we ask, you know, in this diagram, the AI to produce like a fun 3D elephant. That's the prompt. The image that gets produced has a CTPA manifest pointing to the model that made it. The model in turn has a manifest pointing to the data set that made it. And then basically we're using visual similarity matching to identify the relevant subset of that data, basically like a kind of a visual search. And then we trace the owners of those matched images and pay them via the framework, as I say, which in this case was an NFT framework, because that's the way we established the ownership. Now, this problem of identifying responsible training data for a generated image is called data attribution. It's quite a big field now. It's quite an open research problem still. And one problem with the early approach that we did in that AURA work was that it assumes that visual similarity, basically a correlation, implies a causative relationship. And of course, we all know that correlation and causation, very different things. So in later work, such as our ProMark work, we were exploring invisible watermarking of training data to embed invisible identifiers in images prior to using them for training a generative AI model. And the idea then is we are looking to see what sort of mixture of watermarks gets regurgitated in the generative AI images to attribute responsibility in a more causative way. Okay. Now, it turns out this watermarking of training data idea kind of works with training data set sizes in the order of millions, but it doesn't scale to the billion scale data sets that are typically used in modern generative AI. But in practice, we often don't need to protect billions of individual IPs or concepts, as we call them. We want to selectively protect the ones that creators care about. And furthermore, it would be great to do so kind of incrementally without the need to retrain the model as new IP claims and issues arise. So in our latest work, Custom Mark, we do just that. In generative AI, there's this process called customization, where outputs of a generative AI model can be specialized. So, for example, instead of producing a cat, it produces my cat, or instead of producing a person, it produces me, my likeness. This is customization. And the idea here with custom mark is we're going to use customization on the generative AI model to customize a concept to include an invisible watermark, so that specific IPs can be kind of tagged. And then when they get generated, ultimately that tag inside that generated image can be used to trigger payments via frameworks like Aura or like content arcs. So that's the custom artwork. Yeah, so anyway, in conclusion today, I've given a bit of a tour of Provenance and a lot of the work that we've been doing over the last several years. We've looked particularly about how open standards for media provenance, specifically the CTPA standards that, let's say, was initially developed with authenticity in mind, actually forms a kind of capability stack that underpins other important use cases too. So we first of all talked about these three pillars of provenance, these technology pillars, which is fingerprinting, watermarking, and metadata, and how they can create this durable provenance layer. And this helps establish authenticity and ownership of content. And once you've got that, you can start talking about asserting rights over that content and deriving value from it. And ultimately, this is going to lead to new kinds of decentralized platform for recognizing and rewarding content reuse, including for AI, but also for other things that ultimately are a new form of value creation in this creator economy. So is the problem solved then? No. You might be surprised to hear. So, I mean, I'll call out a few kind of working challenges. First of all, like any standards-based solution, right, there's this challenge of uptake and adoption. It's fair to say that CTPA is getting massive adoption in the image domain for provenance. I've talked about cameras, platforms adopting it, a little bit in generative video now and some broadcast demonstrators, but not so much yet in other modalities. And despite this good adoption of the provenance standard, there's no agreed upon standard yet to do rights on top of that. There's some proposals coming out of groups like JPEG Trust, but it's still early days. Second, I mentioned earlier, we need regulation to support respect for these rights markers that are put into content. So, you know, regulation around respecting them, regulation around preserving them and guarding against their removal. This is always possible technically, by the way, so we do need this socio-technical element of the legal support. I'm pleased to say we're starting to see glimmers of this, but certainly not all of it in some of the emerging legislation around AI, like in the AI Acts in China, in the 942 in California, also the EU AI Act as well, are starting to address this issue. And then third, we didn't dive deeply into it, but there are some technical challenges still. You know, the durable aspects of these solutions require registries and federated databases to go look up stripped metadata or rights information. Interestingly, there are kind of early policy ideas like the Creative Copyright Exchange in the UK's industrial strategy that align with this idea, but the governance and implementation of such decentralized databases are kind of undefined at the moment or very early. There are still questions around decentralized technologies as well. I think one of the sort of benefits of the NFT boom and bust era was there was a lot of work put into the scalability of distributed ledgers, but still, you know, there needs to be some further work around scalability and governance and how you can have the two together. And finally, as I mentioned before, there are some other technologies I've mentioned like data attribution that are still on the lab workbench before they can operate at scale. So I'll end the presentation there, and I'm happy to take any questions. As I do so, I'll just put up this slide here, and it gives some information for further reading a lot of the publications we've done in this media provenance area over the last several years. Thank you very much for your time.